we are going to talk about the rate of the reactions. See, by the definition, no need to think much. Rate of the reaction, you can say, how fast the reactions are happening, how much product is forming in a particular time. Okay, so this is called the rate of the reactions. Now, there are three categories of reactions. That is, first one is, the very fast reactions. Very fast reactions. Moderately faster reactions. Then there are some reactions, that is slow reactions. Okay, and we will check each category. What is very fast reactions? See, so the very fast reactions are, nuclear explosion. See, nuclear explosion, you can see it happens in a very exponential rate, just in a fraction of the second, that explosion will happen. Okay, so ഇവിടെ ഒരു nuclear explosion നടക്കുന്ന കാണിക്കാം. Okay. Now there are some reaction that is, as you can see, that is a very slow reactions. Now we can check what is slow reactions. Okay. Slow reactions. See, there are some reactions. For example, I can say rusting of iron. See, rusting of iron, what is happening? Iron, it reacts with oxygen in the presence of water. It forms Fe2O3 or Fe3O4, provided some amount of water molecules shall be attaching. Okay, so this is nothing but a rusting. If I see in a general perspective, these reactions, you can say, like, it happens months. Sometimes it can happen even to the period of years, right? So this is a very slow reaction. It goes on happening in a slow rate. There are some reactions, that is also called moderate reactions. It happens, once it happens, like just within, say, like 1 or 2 days, this reactions, this moderately faster reactions, it get completed. Let's see some examples of that. Concrete setting. Okay, see, the concrete setting is, you can say, like, you are mixing with the sand and you are mixing with the cement. So these two are mixing, it shall form, it shall be forming concrete, right? Concrete. See, when the concrete is forming, very well how many days it will take. Usually, once the concrete is made, it will take some days, like, in order to completely set up a building. So this is nothing but a concrete setting. So you can see the example over there. ഇവിടെ concrete setting in the picture. Okay, so just within 1 or 2 days, maximum 3 days, that concrete, or maximum 1 week, the concrete setting will be completely, it will be set. So this reaction, it is a moderate reaction. So what I am trying to say is that there are very fast reactions, there are very slow reactions, as well as there are very moderately fast reactions. Generally, you have to know chemical kinetics. The speed of the reaction we do not measure in the case of very fast reactions, because who can measure? It is very fast, it happens in a seconds, not in 1 second. It is a fraction of the second this reaction will happen. We cannot measure the speed of the reaction, how much product it is forming in a time. In a very slow reaction, who have that much of patience? It takes years, sometimes months to complete this reaction, very slow reactions. So we generally do not go for measuring the slow reactions also, not necessary also. Of course, there are various approaches to that as well, but that is not in the purview of present discussion. Most of the chemical kinetics studies, okay, the speed of the reaction, we are focusing on moderate reactions. Actually, the reactions that is having, that goes in a moderate speed. Okay, yeah. Okay, so now we can check the rate of the reaction. See, to measure the rate of the reaction, there is a two way. Either we can measure the product changing per time, or we can measure the rate of the reactant it is depleting per time. In order to demonstrate that, I can just write a reaction that is Z10 plus H2SO4. If you put zinc into sulfuric acid, it is going to produce zinc sulfate plus H2. Okay. See, remember one thing here, that when the reaction is happening, the amount of zinc it will be keep on decreasing, because zinc is reacting and it is forming zinc sulfate, right? And so here the amount of zinc it is actually getting completed, okay, and more amount of hydrogen, the amount of zinc sulfate is keep on forming, and amount of hydrogen is also it is keep on forming, right? The hydrogen gas also it is keep on forming. So there are four strategies. Either we can measure the decrease, okay, either we can measure the, I can write here, okay, so we can measure the decrease of zinc, and we can also measure the decrease of H2SO4, and we can measure the increase of hydrogen gas. We can measure the increase of zinc sulfate. Okay, so to measure the decrease of zinc, it is not easy actually, or like a sulfuric acid, because it is in the liquid state. We don't know how much amount of sulfuric acid concentration is decreasing. The easiest one is whenever there is a reaction that is releasing a gas. We know very well hydrogen it is a gas. So this gas it releases. H2 gas it is releasing. Whenever there is a reaction, it is releasing a gas. Then what we can do is, we can collect the amount of gas. Okay, easily we can collect the gas. For example, you think in this way. This is a reaction. This is a bubble. So from here, if you are collecting the gas using a syringe or like a piston, so then the gas can be collected. Actually, this gas it will enter. So initially, how much volume? Let it be 10 centimeter cube volume gas might be collected. So or less than that gas might be collected. Okay, and how much time it took for the collection of this 10 centimeter cube of gas. So based on that, we can calculate the rate of the reaction. So the reactions that is releasing the gases, let it be hydrogen, oxygen, chlorine or carbon dioxide, or whatever the gases it may be, if the gases are collecting, okay, then based on the amount of gas it is releasing, we will find the reaction. For example, suppose here this 10 centimeter cube of hydrogen, it got released in say like 10 minutes. Then the rate of the reaction is very simple. So 10 centimeter cube gas per 10 minutes. So it's going to be, I can write here 1 centimeter cube per or centimeter cube, or you can say milliliter, 1 centimeter cube per minute. This is the rate of the reaction. This is the rate of the reaction, right? So So we can either actually change decreasing, we can either actually check the look for the decreasing the concentration of reactants or increasing the concentration of products. Any one of these things, we can look for. Okay. So I hope you got it. Now we are going to check into how we can measure the measurement of the rate of the reaction, that is in the next section. Okay.